Okay, good morning, good afternoon to you, wherever you are. Today we're going to talk about circles and circumferences. Not a hard assignment. If you're following along in the book that we use, it is 10-1. All right. And this lesson's not hard, but what we're really going to be doing here is just establishing some of the words that we're going to use a lot. Okay. So if we look at a circle, and the best way to do this is just mess around for a few minutes. Okay. We're going to talk about some words. Some of the words I might go a little bit farther than what's going to be on the lesson. But if you have a circle, right? Well, you should already know that a point from the center of the circle out to an edge is called a radius, right? You should already know that, right? And if that line goes through the circle all the way through the shape, we call that a diameter, right? That's a diameter. Now we're going to learn some words that you may not know. If a line segment cuts through the circle in two spaces, right, like here and here, this is called a chord. All right. And there's one other one I don't think we're going to be talking about today, but if you have that's a line segment cutting through a circle, but if you have a line that cuts through a circle, right, just keeps cutting through it, that is called a secant. All right. So point from the middle of the circle out to an edge, radius. A line that cuts through the circle through the middle, touching both sides, is called a diameter. A line that cuts through a circle a line segment that connects 2 points on the circle, that's called a chord. Incidentally, a diameter is a chord also, okay? But it's a special chord. It's the biggest chord that you can make inside of a circle, okay? And then you have this one that we're not going to probably talk about today, a line that cuts through the circle is called a secant. Okay, so those are some words we need to know. Now we can name things like this. All right, a segment with endpoints that are on the circle and on this that are on go through the center. Wow, messed that up, didn't I? A segment that goes through the center of the circle is called a radius, right? A segment with endpoints on the circle is called a chord, and a chord that passes through the center is also called a diameter. Okay. Okay, so for the circle that has a radius r and a diameter d, the following are true. So if the radius, let's say the radius is 1, right? If the radius was 1, the radius is also equal to the diameter divided by 2. And that makes sense, right? This is a radius, and this is also a radius, so 2 radiuses make a diameter. I think you've learned that probably somewhere around 5th or 6th grade, right? So if the radius is 1, then the diameter is 2, right? Or the radius is half of the diameter, right? That's all that's saying there. Pretty simple. All right, name the circle. All right, so the way you name circles is you name it by its center. So you can call this circle, and all you have to say is, where's the center of that circle? The center is at O. So it's circle O. Another way you can do it is you can make this symbol, right? That's the symbol, circle O. I kind of wish, you know what, can we call this P just so I can not have double O there, right? So let's call this P, circle P or circle P like that. Both mean the same thing. Radiuses. All right, so when you name a radius as a circle, you need to name it from the point that it starts at, right, the center, out to an edge. So you can call this radius PB, right? You can call it radius PD. And there's lots of other ones that work here, right? They're all just radiuses. PB, PD, PC, PA, they're all radiuses, all right? Name chords of the circle. So we have, now chords are line segments, not lines. So let's name some chords here. Well, if you look at this shape, there's really only 2 chords here. This is a chord, right? This one right here, and that one's a chord. This one right here that I'm about to draw, that is not a chord, because a chord has to go all the way touching 2 sides of the circle. So it's not a chord. So we have chord AB, and notice it's a line segment, not a line, right? Chord AB, and we also have chord CD. Right? Incidentally, if I was another way to write a radius, so if I wanted to go back to B, PD is a radius, right, of the circle, and it's a line segment, so you could say PD like that. You could say radius PB, or you could also just say line segment PD. All right. Name the circle. All right. Well, this is circle R. Pretty easy. Name the radius of the circle. Name the radius. Well, RB is a radius, right? Oh, it says radii. That means more than one. So there's a bunch of radiuses here, right? RB, RX, RA, and RY. Name chords of the circle. Well, chord AB, chord AX, right? That's AB is a chord, AX is a chord. Remember, diameters are chords. Chord XY, and also chord YB. Name the diameters of the circle. Well, there's only two, right? Line segment AB and line segment XY. Okay, if AB, what are they saying on it? Question 5. If AB is 5, oh, sorry, 18, not 5. If AB is 18, then find AR. Well, AB is 18, so half of AB is AR, right? So it's 9. So AR equals 9. If RY equals 7, so if this is not, why do I keep making up numbers? If RY equals 10, then find AR. Now check this out. Some people have to make this mistake. Well, RY is a radius, and AR is also a radius, and AB is a diameter, right? So if RY, if this is 10, then AR must also be 10, because all radiuses are equal, right? So we know AR is 10. And AB is the diameter, so AB is just twice as long, so it's 20. All right, is AB congruent to XY? The answer is yes. Yes, they are. So why is that yes? Well, because they're both diameters of the same circle, right? That's a diameter, that's a diameter, and so a diameter is just two radiuses, so yes, they're both diameters of circle what? Circle R, right? All right, pretty easy. All right, now we're going to get into a little bit more mathy kind of stuff, right? That was just kind of establishing some rules of circles. Now we're going to do some math, right? All right, so circumference. Circumference is equal to 2 pi r, or circumference is equal to pi d, all right? Let's have this little side conversation real quick. If circumference is equal to pi d, then that must mean that pi is equal to circumference over the diameter. And that is true. Check this out. If you had a circle, right? And you found the circumference, you measured it, right? And that's some number. Let's call that number A. Now let's call it C for circumference, right? If you found the diameter of that same shape, right? So we just found the circumference. If we then found the diameter, and we took the circumference and we divided it by the diameter, we would notice that it's always 3.1415, blah, 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 right? The pi is just the circumference divided by the diameter, right? And that's a universal truth. Pretty neat. All right, circumference is 40. Find the diameter and the radius of the circle given the information. All right, well, we know circumference equals pi d, right? So if the circumference is 40, then we know that 40 equals pi d. So d must equal 40 over pi. And we're going to write these in pi units, and then if on your homework, I'm not going to do this for every one of these, but on your homework, you're going to have to get out a calculator, right? And you're just going to have to figure out what 40 divided by pi is. So 40 divided by pi, keys down here, right? So 40 divided by pi is about 40 over pi, nice. All right. It's about 12.7, right? Oh, it says to the nearest hundredth, so let's see. Let's go to the nearest hundredth. So 12.73. So it's 40 pi or 12.73. And it's in inches, right? Now the diameter is 40 over pi, so the radius, if the diameter is 40 over pi, then the radius is 20 over pi, right? And the radius is also equal to, what is 20 divided by pi? 20 divided by pi is about 6.37. 6.37, so about 6.37. That's it. Pretty easy, okay? I'll do at least one more of these. Let's do, I guess, let's do 4 just to spread it out a little bit, okay? So we know that circumference is equal to pi times the diameter. And we know the circumference is 9, so 9 equals pi d. So d must equal to 9 over pi. And then you would calculate that as a diameter. I'm sorry, as a decimal. Calculate that diameter as a decimal. So go figure that out, right? So 9 divided by pi. Control enter. What is that? 2.86. 2.86. Which would mean the radius is half of that. So it's 9 over pi over 2 pi, right? Because you're dividing it by 2. So 9 over 2 pi. All right, well, what's 9 over 2 pi? 9 divided by 2 pi. Oh, I'm not even typing. No wonder. 9 divided by 2 pi is around 1.43, right? So around 1.43, although you could have just taken half of that, right? Pretty easy. Okay, so let's try example 7 now, right? Now they're going to give you side lengths of a triangle that's inscribed inside of a circle, right? Inscribed means drawn inside of the shape, right? And what you're going to do is find the circumference of that shape. Well, in order to find the circumference, you need to find the diameter, right? Because circumference is equal to pi d. So we need to find the diameter. Well, that's pretty easy because this is the right triangle, right? That's a 6, 8, and you should know your Pythagorean triples, right? 6, 8, 10. If you don't know your Pythagorean triples, try it out. 6 squared plus 8 squared is 10 squared. So we know this is 10, which means the circumference is pi times 10, or the best way to write that is 10 pi. And I want you to notice it says find the exact. Exact circumference means you write it in pi units, okay? So find the exact means to write it in pi units. So the circumference is 10, the circumference is 10 pi centimeters. All right, number 8. All right, so that's 9, and they say these are equal, so this is also 9. Now you could go through the Pythagorean theorem, right? And you could say 9 squared plus 9 squared equals the diameter squared, which is what? 81 plus 81 equals d squared, which is the same as 2 times 81. Watch this little clever way of doing this, right? It's equal to d squared. You square root, you square root. So you'd end up with 9 root 2. But check this out. You probably should have already known it was 9 root 2 because if that's 9 and that's 9, that is like a 45, 45, 90 triangle, right? And remember, 9, 9, this would be 9 root 2. S, S, S root 2, right? So this would be 9 root 2. So hopefully, use your 45, 45, 90 triangles on this tonight. So the circumference is equal to pi d. So the circumference is equal to pi times 9 root 2. So it's 9 root 2 pi inches. Pretty easy. All right, example 9. Well, this is 3, that's 7. I don't know a Pythagorean triple for 3 and 7. So I'm just going to do it. 3 squared plus 7 squared equals diameter squared, right? So 9 plus 49 equals d squared. 49 plus 9 is 58, so 58 equals d squared, square root, square root. So d is equal to root 58. So there we go. The diameter is root 58. Circumference is equal to pi times the diameter. So it's pi times root 58. So the answer is root 58 pi. All right, next problem. Well, first of all, you have to know these are 2, right? Each side is 2. All right, and we need to find the diameter first. Well, the diameter is this distance, isn't it? That's the diameter right there. Oh, once again, that's a 45, 45, 90 triangle. So that'll be 2, 2. This will be 2 root 2. So the circumference is pi d. So the circumference is pi times 2 root 2. So the answer is 2 root 2 pi units, right? All right, example 11. All right, inscribed triangle, 5, 12. You should know by now a 5, 12, 13 triangle. If you've been following along in my classes, that should be pretty easy. That's going to be 13. So circumference is equal to pi times the diameter, so it's pi times 13. So the circumference is 13 pi centimeters. All right, one more problem. Example 12. Those are both root 2, which means this is a 45, 45, 90 triangle. So this is going to be equal to root 2 times root 2, times root 2, right? Because it's s root 2. And root 2 is 2. So the circumference is equal to pi times the diameter, which is 2. So it's 2 pi centimeters. And that's all there is to this. It's not hard, right? Really, this lesson's about learning about chords and radiuses and diameters and doing some basic math. We are going to explore a lot more detail about all the characteristics of circles and all the things you can do with circles. So this is just an introductory lesson. Shouldn't be that hard. If you have any questions about it, send me an email at MathNinjaVideos@gmail.com or leave a comment on my YouTube channel. Good luck with this and have a good day.